Today we're going to look at what are rational exponents. So the first thing we want to make sure we understand is what does the word rational stand for. So the word rational means fraction. So it's kind of a fancy word for a fraction, but a very specific type of fraction where the numerator and the denominator are whole numbers or integers, and they cannot be decimals. So we're going to see what happens when we have exponents that are not whole numbers, but they're fractions. So that's what we're going to be looking at. So these are examples of rational exponents. So all the exponents are fractions, not whole numbers. So if I wanted to figure out 8 to the 5/3, it's not like I can say write down 8 5/3 times because it's a fraction. It's not a whole number. So what do these exactly mean? So let's go ahead and go back to that there is really an invisible 2 on the top left-hand side of the radical sign. We just don't write it because the square root, square standing for the power of 2, square root has a power of 2 kind of on it, but we actually write it here if we were to go ahead and write it. But we don't write that 2 generally because the square root is a more common root that we write. But there technically is a 2 in that spot. So another way to write this is using a fraction. So fractional exponents are really where our square roots come from. So instead of having to write down a fraction each time when we want to write down something to the power of a fraction, someone decided that we're going to just write it as a radical. So square root of 16, which has that little 2 on it, is really 16 to the power of 1/2. These two things are equivalent. This is a definition in mathematics. So at the end of the day, we have that these two are equal. The square root of 16 is equal to 16 to the 1/2 power. And this is just a definition we need to get used to seeing and using. All right, so what if you change the root? So we don't only have the square root, otherwise we wouldn't need to put that little 2 or decide that there's a 2 there. There's actually something called a cube root or a 4th root or a 5th root or a 10th root or a 45th root. There's tons of different types of roots. You don't generally see them often, but they do exist, and the most popular one is the square root, but there technically is something called the 4th root, and it has its own fraction as well, which would be the 1/4 power, and these are equal to each other. But what if the base number already has an exponent? So let's say the 16 itself had a power that was a whole number. Let's say, for example, 3. So we would rewrite this not as 16 to the 1/2 power, but that 3 would say we have to do 16 to the power of 3, meaning the following. I would take this whole thing and do it to the power of 3, but I know I have this thing called the power rule, which means I would multiply 1/2 times 3, and if I multiply these, I would get 3/2. So I can just replace the 1/2 for 3/2 power. So when we have a power on the base of our square root, we end up with a fraction still, but now the numerator is no longer 1. It's that number that we have on the base as a power. All right, so here's a way to help you remember this because it's usually confusing going back to the previous one. Which one's the one that's in the index and which one's the power of the base, the 3 or the 2, and it's kind of hard to remember sometimes. So here's kind of a memory trick that I tell students. So think of a tree. Trees have roots, just like the square root. So think of the word root in the square root or cube root or 4th root, and think of a tree that has roots. And where are the roots on a tree located? They're located at the bottom. So that can help you remember where the root one goes. So just like a tree, the roots are at the bottom. So just when you have your actual fraction, the root is the one on the bottom of the fraction. So that can help you remember that this one, 16 to the power of 3/2, the half is at the bottom. So that would tell me it's a square root. So when I write it over, I would make sure the square root has the number 2 because the root is at the bottom, square root. So if I have x to the 5/3, which one's my root? The 5 or the 3rd? Is it going to be a 5th root or a cube root? And just like a tree, the root is at the bottom. So I would say it's a cube root here, and it's going to be x to the 5th power. So the root always goes at the bottom of the fraction in case you are trying to remember which one goes on the root itself. All right, so let's go ahead and go back to something we were doing earlier when we were solving equations. And I always told you guys that a square cancels a square root. You just cancel them out and that's x. But why is that true? If I have a cube root and a cube, these cancel each other out. So cubes cancel cube roots. So why is it that they cancel each other out? So let's go ahead and look at a quick example. Let's say I have the root of x cubed. Yeah, let's go back to this one. No, actually, let's put a number on it. Let's say we have the 8th root cubed to the power of cube root of 8 cubed. So what this means, remember, if I rewrite this, actually, let's not put a 3 on this one. Let's just go cube root right there. Let's say I have this, and I look at this cube root. I can rewrite this as 8 to the power of 1/3. All right, using the rule, the root is at the bottom, right? But now let's say I take this and I take it all to the power of 3, which means I'm going to take this one to the power of 3. What I do to the left, I do to the right. And like I said earlier, this cancels that. But why does it cancel it? So let's look at the right side to see why it cancels it. So this is 8. Using my power rule again, I'm going to multiply 1/3 times 3, which gives me 3/3, which is equal to 1. So it's a first power. So you can see that these are now equivalent. So the reason they cancel is because the root is a fraction that has this number at the bottom and has this number at the top, and they divide each other out to make it a power of 1. So that's why we can always cancel anything that's like that matches on the index and on the power. So these can always cancel, and the base will always be freed up. Same thing if I were to do something like x squared to the 7th power, all to the power of 7. The 7th power will cancel the 7th root, and here I would just get x squared. So just remembering that a root will always cancel with a power if the index matches. So let's actually go ahead and I'll start working on the notes just to make sure we have that going. Let me see if I can find it. There we go. So we're going to go ahead and start filling this out. So for the first one, I just want you guys to put that this is the same thing as 16 to the 1/2 power. And if you want, go ahead and put the little 2 on there because the index would be 2 on that one. Let's move on to the next one. Let's say we have a 4th root here, and this would be 16 to the 1/4. Let's say this next one we have a cube root, and let's say we put this all to the power of 5. So we'll write this as 16. When we write our fraction, the root goes at the bottom, so the 3 goes at the bottom and 5 goes at the top. So just in general, we're going to write down in this box fractional exponents. I'm going to clear this out. And we're going to go back to the PowerPoint where we left off. We're going to write this quick phrase out. So in that box, I want you guys to write down the phrase. Just like a tree, the roots go at the bottom. So please go ahead and write the following down in that box on your notes. Pause it, because I'm going to keep on going. All right, now that you have that written down, we're going to get into just like the definition here, the exponent. When the exponent is a rational or a fraction, we call it a rational exponent. Rational exponents represent both an integer exponent and an nth root. The root is found in the denominator. Again, the root is at the bottom, and the integer exponent is found in the numerator, the one that's the regular power. All right, and that's just kind of the vocabulary, the little on the right side. The B in blue is the index. The A in the X, the green X, is the exponent. And we call that the radical symbol, and the radicand is whatever is inside the radical. Notice it says B cannot equal to 0 because we don't have a 0 root. Let's go ahead and look at our examples now. We're just going to go ahead and convert these into radicals or into fractional exponents based on how they're starting off, and we're going to evaluate everything. So for this first one, we're going to say this is x. The root is a 7th root because we have a 7 on the bottom. Just like a tree, the roots are at the bottom to the power of 2. So you can write it like this, or your other option is the 7th root of x all to the power of 2. I generally like the first one because it's a little cleaner. You don't need the parentheses. I'm just going to be doing the top way for the rest of these. So this is the 3rd root, or the cube root of w to the power of 5. Here we have the square root of 25. I'm not going to write the 2 because we don't need the 2 on the square root to the power of 3. But this one we can actually evaluate it. So I'm going to do this one this way because we know the square root of 25. That's 5, and we're going to cube that. That's going to be 125. Look at the next one. We're going to have the 5th root of x to the 3rd power. Next one we have 27, and it's going to be a cube root of 27 to the 1st power. We don't need that one. And the cube root of 27, remember, It's what number multiplied by itself, but this time 3 times, not because it's not a square root, is 27, and the answer is 3, because 3 times 3 times 3 is 27. All right, here we have a square root of 9, and this is going to be to the power of 3. I'm going to put it in parentheses to the power of 3, because I can actually evaluate this, because it's a number. So what's the square root of 9? 3, and 3 cubed is 27. All right, let's go ahead and move on to the next ones. And we have the cube root of m4, m to the power of 4. So I'm going to write this as a fractional or rational exponent. So I'm going to write the fraction. It's going to be 4 over 3 because the root is at the bottom. Here's going to be 32 to the power of 6 over 5. And we're going to go ahead and, actually we can't evaluate this because no number multiplies by itself 5 times to give us 32 unless it's a decimal. We'd have to use a calculator for this. All right, next one we're going to have x to the power of 7 over, and what's the invisible index on this? That's a 2, so 7 halves. Next one we have 12 to the power of 3/8. Next one we have y to the power of 9 halves, because remember, that's square root, the index is 2. And last one we have m to the power of, the root goes at the bottom, and we have an invisible 1 there, so that's going to be a 1/8. So that's the general idea of how to work with fractional exponents. We can still apply power rule, product rule, quotient rule with fractions. We'll just have to add and subtract and multiply with fractions, and you guys know how to do that. So you'll be doing that on your practice. So go ahead and get started, and good luck.